Alright, somebody tagged me under a comment section that solar analyst. If I have a 3 kVA 24 volt and a 3 kVA 48 volt with 4 battery each, which one is going to back up better? And I asked him under the comment section that before I could answer you correctly, I need to know, are those batteries the same? The inverter, is it the same inverter from the same factory, the same company? Do they have the same power factor, and are they also running the same amount of load? So these are the critical questions I wanted him to provide me an answer. In the acceptance of his reply, let me proceed and do an assumption, and let's assume that all the load, everything requested are of the same capacity. Now let me break it down. The inverter involved is a 24 volt 3 kVA inverter, a 48 volt 3 kVA inverter from the same company, the same manufacturer, and each of them is going to be running with 4 pieces of 220 amps tubular battery, and also this one also is going to be running with what? 4 pieces of 220 amps tubular battery. Now one thing you need to understand is this battery is 4, this one also is 4. One is 24 volt, the other one is 48 volt. For you to achieve your 24 volts, you have to do what we call a parallel series connection. When you do a series connection, you get your 24 volts. Then you now do a parallel connection, you still get your 24 volt. That means you will have a 440 amps 24 volts for this one. Then you will have a 220 amps 48 volts for this system. If you do a series parallel connection for this, you have the 440 amps connection for this 24 volts, and you have the 220 amps connection on 48 volts. Now that is very clear. Now the total amount of energy in this cell, are they the same? Yes, the total amount of energy, they are the same. That is what? 12 volts multiplied by 220 amps multiplied by 4. That means the total amount of energy in the battery cell is 10,560 watt hour. This one also is what? 10,560 watt hour, regardless of either being watt hour, either being a 24 volt or 48 volt. The amount of energy in the battery cells are the same. So let's assume that this battery has a DOD of the same voltage. That means we have to do what is the DOD, because we are looking at it as if everything has the same capacity. Therefore, the DOD which I look at, because majority of all these tubular batteries has 40, we have the one that has 40% DOD, 60% DOD, 80% DOD at a critical level. Let's assume that we are using a 50% DOD. Why did I say? We are using what? 50% DOD. So we want to look at it. Let's assume we are running 1000 watt load on the system. We are running it with what? 1000 watt load. We are also running this one also with what? 1000 watt load. What is going to be our likely backup power? That is equal to what? 12 volts multiplied by what? 220 amps multiplied by what? How many units? 4. Multiplied by what is back DOD? These are DOD 0.5%. Yeah. What is the total load? That is 1000. Therefore, what is going to be our backup hour? That's going to be what? 12 volts multiplied by 220 amps multiplied by 4 pieces multiplied by 0.5 is equal to 5,280 divided by 1000. So our backup hours expected is what? 5 hours 28 minutes. Theoretically, they are going to back up at the same time. Now let's go back. Technically, our 48 volt system will be running with 1000 watt load, and also our 24 volt will be running with what? 1000 watt load. The current which they are going to be discharging, let's take a look at it. 10,000 1000 watt load divided by 48 volts, you have 20.83 amps. Likewise, our 1000 watt divided by 24 volts, you will have 41.67 amps, which means your 24 volt will be discharging at a higher rate, higher current. That is what I mean. And why this one will be discharging at a low current? When there is a higher discharge of current and there is a lower discharge of current, three things is going to happen. When you look at the heat, temperature, everything, this your 48 volt is going to last longer technically than your 24 volt, because the current of this one is higher. You will need a very strong cable. There won't be heat loss, there won't be any temperature. So your 48 volts in terms of discharge and in terms of charging, this is better. Thank you.